Good morning. Today you're going to learn about different problems regarding Newton's laws of motion. Okay? As you can see here, we have a problem regarding Newton's first law of motion. The problem statement proceeds as consider a traffic light mass of 15 kilograms suspended from two wires. Find the tension in each wire, neglecting the masses of the wires. Okay? As you can see here in the figure, we have two wires. The other one makes 30 degrees with respect to the horizontal. Then the other one labeled as T2, why T2? Because it has a tension, makes 45 degrees with the horizontal, and then an arrow pointing downwards with W, which represents the weight of the traffic light. And now, if we're going to further simplify the free body diagram, which is the first step on illustrating your solution, you must provide a free body diagram. Okay? As you can see here, your first cable has first tension labeled as T1, okay, with following components, vertical components Ty and horizontal components of T1x. Okay? And then if we're going to consider the second cable, it has T2x as x component or horizontal component and T2y as vertical component. Now, how are we going to solve the forces? The first thing, since this is not an accelerating traffic light, it stays stationary, okay, supported by two cables. The summation of horizontal forces would be equal to zero, as summation of Fx is equal to T2x minus T1x. Why is your T1x minus? It is minus because it is pointing towards your left, okay? Following Cartesian plane coordinates. Now, if we're going to further simplify this one, since T2x minus T1x is equal to 0, transpose to the other side of equation your T1x, so T1x is equal to T2x. But further simplifying your x components of first and second cables, we're going to use trigonometric identities, getting now the um, x component of your first cable, okay? Since we are given with the angle, and then this is an adjacent, and then your T1 here, or your tension one here, is your hypotenuse, getting your T1x in terms of your angle and your hypotenuse, use cosine. So this becomes T1 cosine of 30, and then equate it to the um, horizontal component of your second cable. So it becomes T2 cosine 45. Now we have established our first equation with T1 and T2 as your unknown variables. To get the, since we have two unknown variables, we need another equation, okay, to solve two equations and to determine the values of the two unknowns. So we're going to get the second equation. We need to establish our second equation through summation of forces vertical and then equate it to 0. As you can see here, I'm going to highlight this one. Summation of vertical forces is equal to 0. So summation of Fy is equal to T1y plus this must be T1y minus W. Your W here is the weight of the traffic light, and then equate it to 0. So it becomes T1y plus T2y is equal to W. So how are we going to get now the um to further expound the y components of the forces? Okay, your y component of the first cable here, since we are given with this one, okay, and then your T1 here, and then the angle 30 degrees. So given as opposite and then the hypotenuse as T1 gives us T1 sine 30 plus T2 sine 45 for the second cable, then equated to the weight of the traffic light. But further simplifying the weight of the traffic light makes it mass times gravity. So 15 kilograms times 9.8 meters per second squared. So this one, the whole equation we had established is the second equation. Now, if we're going to further simplify this one, we're going to substitute your first equation as T1 is equal to T2 multiplied with cosine 45 degrees all over cosine 30 degrees. Okay, substitute it to second equation. Gives us values for T1 would be equal to 108 newtons and T2 132 newtons. Okay. This is substituting your first equation to second equation and simplifying the whole equations. Okay. Now let's proceed with our second law problem. Two tugboats push on barge at different angles. The first tugboat exerts a force of 2.7 times 10 raised to 5 newtons in the x direction, and the second tugboat exerts a force of 3.6 times 10 raised to 5 newtons in the y direction. The mass of the barge is 5 times 10 raised to 6 kilograms, and its acceleration is observed to be 7.5 times 10 raised to negative 2 meters per second squared in the direction shown. What is the drag force of the water on the barge resisting the motion? Okay. As you can see here, this is the barge. Okay. The first boat or first tugboat exerts a force of 2.7 times 10 raised to 5 newtons. The other one exerts a force of 3.6 times 10 raised to 5 newtons. Okay. Hence, the whole barge moves at an angle of 53.1 degrees. Now, how are we going to solve the unknowns? Okay. The unknown here in the problem is the drag force of the water on the barge. Okay. After illustrating the problem, we are going to determine the free body diagram. Okay. As you can see here, your FD is the drag force, and then we have your force 1, 2 here. As it pushes on this side, if you're going to further simplify the free body diagram as barge being your point of origin, okay, your F1 now points to your right, and then your F2 points upwards. Further simplifying this one gives us an angle of 53.1 degrees subtended with the force applied and the first force of the first tugboat. Okay. Yeah. Now let's proceed with the solution. We are given with the known variables as F1, F2, the mass, and then the acceleration. And then the unknown variable here is the FTR force drag. How are we going to solve now? F up pertains to the resultant forces or the Pythagorean hypotenuse of the forces F1 and F2. Hence, your F up here is actually the net forces of your F1 and F2. How are we going to solve now your net force or your F up? Okay, your F up would be equal to the hypotenuse. No, the Pythagorean application, okay, the square root of your f1 squared plus f2 squared gives us 2.7 times 10 raised to 5 squared plus 3.6 times 10 raised to 5 squared, giving us f up in equal to 4.5 times 10 raised to 5 newtons. Okay, how are you going to determine your resultant angle? Your resultant angle now would be equal to the arctangent of f2 all over F1. Your F2 here is the vertical force all over the horizontal force. Your F2 here, as illustrated, is the force exerted by the second tugboat. Okay. Substituting now the values, we have your arctangent of 2.7 times 10 raised to 5 newtons all over 3.6 times 10 raised to 5 newtons gives us 53.1 degrees. Now solving for the F drag. If we're going to establish equation for the F drag, your F up or F net would be equal to F up minus the force drag or the drag force, okay, from the water. But since this is the second law of Newton, okay, where F net is equal to mass times acceleration, so this variable would be equated to mass times acceleration, okay? Further simplifying the whole terms for transposition of your FD would be equal to F up minus mass times acceleration. Remember from the problem, the mass and acceleration are given as 5 times 10 raised to 6 kilograms and 7.5 times 10 raised to negative 2 meters per second squared respectively. Plugging in the values gives us an answer of 7.5 times 10 raised to 4 newtons for the drag force. So that is the force exerted by the water on the tugboat. Okay, let's proceed. We have a combination of second and third laws. Okay, a 75 kilogram man weight of about 165 pounds standing on a bathroom scale in an elevator. Calculate the scale reading if the elevator accelerates upward at a rate of 1.20 meters per second squared. And then for letter B, if the elevator moves upward at a constant speed of 1 meters per second. Okay, we are given with the following. We have the mass of the man as 75 kilograms. How are we going to solve the part for letter A? Okay. Calculate the scale reading if the acceleration rate is 1.20 meters per second squared, and the movement of the elevator is upwards. Okay. The various forces acting when a person stands on a bathroom scale in an elevator, the arrows are approximately correct for when the elevator is accelerating upward. Broken arrows represent, okay, I'm going to zoom out, represent forces too large to be drawn to scale. Your T is the tension supporting the cable. W is the weight of the person. Okay? And then WS is the weight of the scale. WE is the weight of the elevator. FS is the force of the scale on the person. FP is the force of the person on the scale. FT is the force of the scale on the floor of the elevator. And N is the force of the floor upward on the scale. The free body diagram shows only the external forces acting on the designated signs of the interest, okay, of the person, and is the diagram we use for the solution of the following problem. F net now would be equal to F up minus FD, okay? And then Fs minus the weight would be equal to mass times acceleration. Fs is equal to mass times acceleration plus the weight. But take note, your W or weight would be equal to mass times gravity. Okay? Further simplifying for letter A, if A is equal to 1.20 meters per second squared, your Fs would be equal to 75 kilograms multiplied with the gravitational acceleration on Earth plus 75 kilograms times the acceleration of the elevator itself. Okay, gives us an answer of Fs is equal to 825 newtons. And then constant speed of 1 meters per second for letter B. Note, if constant speed, okay, this is actually first law of Newton. Okay, acceleration is equal to 0, A is equal to 0. So F of S is equal to mass times acceleration at, and you're going to add mass times gravity. F of S is equal to mass times 0. So this quantity makes it 0. So your F of S now would be equal to the weight of the person as 75 kilograms times 9.8 meters per second squared, giving us your Fs at 735 newtons. Okay. So this is a common board exam problem question. So we have to determine or establish equation for this type of figures. We are given with first block here with mass of M1 and then a carrying mass here M2. Okay, since the motion of the whole figure is downwards, whereas your A1 is moving towards your right, and then your A2 or the acceleration 2 of this second mass here is moving downwards. Hence, your M2 is heavier than your M1. Okay? To establish the equation, we have to separate the block diagram of each, namely a separate figure for your M1 and a separate figure for your M2. For the separate figure of your M1, the free body diagram goes through this. Your weight 1 is pointing downwards. Weight 1 is affected by the mass of the block 1, M1. And then remember that normal force is the force perpendicular to the surface. Okay, so it points upwards. And then we have this tension here pointing towards your right. Okay. For the free body diagram of your second block here, the tension is pointing upwards and then the weight points downwards. Okay. Weight here is affected by the M2. For the balancing of forces, for block 1, your tension now would be equal to your block 1 T plus W1 plus N be equal to your mass of the first block times the acceleration of the first block. And then we have the tension here for the second block plus the weight of the second block would be equal to the mass of the second block multiplied with the acceleration of the second block. Okay. If we're going to consider the component, okay, for block 1, we have this one. Summation of f of x would be equal to mass times acceleration of ax. Tx now would be equal to m1 a1x. And then for the second block, we have the summation of fy. It doesn't have it doesn't have what do you call this? X component because your second block has vertical forces only. So Ty now minus M2 would be equal to M2 multiply it with the acceleration at the second block. Further simplifying the following equations, okay? This is your first equation, this one. Then this is your second equation. Simplifying it, where tension would be equal to M1 multiply it with your A, and then your tension here, substitute it to your second equation here. Simplifying, we get for the acceleration, A is equal to M2 multiplied with your gravity all over the first mass plus second mass. And then to get now the tension, since Tx here is equal to Ty because they are connected in a single cable. Okay? Tension here, T is equal to M1 multiply it with your M2, multiply it with your gravitational acceleration, usually Earth, all over summation of both masses of the blocks. Okay. So we have this Atwood's machine formula. The Atwood's work like this. So a pulley is connected here, and then two blocks counteracts the whole system. If we're going to separate the free body diagram of the first block here with mass of M1, your tension points upwards, and then the weight of the first block points downwards, and then same goes with the second block, okay? Although the variables are different. The second block with mass of M2, its tension is pointing upwards and its weight points downwards. The acceleration here, A, would be equal to the second mass minus the first mass, or the mass of the second block minus the mass of the first block, multiplied with the gravity all over the summation of the masses of blocks 1 and 2. And then for the tension, you're going to solve it through multiplying the first um, mass, or the block of the first, the uh, mass of the first block, multiply it with gravity plus acceleration. Okay? And then we have this one, a simple problem here. The soccer player starts at rest and accelerates forward, reaching a velocity of 8 meters per second in 2.50 seconds. What is her average acceleration? For letter A, and then for letter B, what average force does the ground exert forward on the runner so that she receives this acceleration? The player's mass is 70 kilograms and the air resistance is negligible. So we are given with the following variables. This one is your final velocity, and then at rest makes it initial velocity, and then this is your time. And then the 70 kilograms is actually the mass of the player. So how are you going to solve for the acceleration for letter A? Your average acceleration, okay, from our previous discussions, that is equal to delta V all over delta time. Okay? Hence, your acceleration here, 8 minus 0 all over 2.50 minus 0, makes it 8 all over 2.50, or 3.20 meters per second squared. To determine down the total force exerted, okay, your F net would be equal to mass times acceleration. Okay? The mass of the player is 70 kilograms. Multiply it with the solved acceleration on part A as 3.20 meters per second squared gives us an answer of F net would be equal to 224 newtons. Okay? And then for the vector method, a 1.50 kilogram model helicopter has a velocity of 5.0 j meters per second at time is equal to 0. Okay, initially, um, your time is equal to 0, so the velocity is at 5.0 j. It is accelerated at a constant rate for 2 seconds. Okay? After which, it has a velocity of 6I plus 12 j meters per second. Okay, this is the final velocity. What is the magnitude of the resultant force acting on the helicopter during this time interval? So let's define the given variables. We have the mass as 1.50 kilograms in a time of 2 seconds. And then this one is actually your final velocity. And then the 5j here is your initial velocity. So solving for the acceleration, since this is in average, because we're going to deal about final velocity and initial velocity, so we're going to subtract both. Okay, plugging the values gives us 6I plus 7j all over 2 seconds. Okay, take note. Force is equal to mass times acceleration. So substituting the values here gives us 4.5I plus 5.25j. Note that I and j stands for x and y components. Okay, I repeat, I and j stands for x and y components. Thus, f of x here is equal to 4.15 newtons, and f of y here is equal to 5.25 newtons for j. Now, determine the F net. Okay, what is the magnitude of the resultant force or F net? You're going to use the Pythagorean theorem, the square root of your f of x squared plus f of y squared or f of I squared plus f of j squared. Okay, further simplifying this one as the square root of 4.50 newtons squared plus 5.25 newtons squared, giving us an answer of 6.91 newtons. So that concludes my presentation for now. I have tons of problems you can review, okay? Some of which integral, differential and integral calculus were applied. So please be guided accordingly for my class. For any questions, you may message me through my messenger account or through our LMS inbox. So thank you for listening. Have a nice day.